let's see how static routing can be configured for IPv6 networks. IPv6 is Internet Protocol version 6, which is replacing IPv4 because of the lack of IP addresses provided by v4. Now let's consider this example. Here we have 3 LANs and 2 serial networks. Let's see how IPv6 addresses can be configured for the devices that are present over here. For example, for PC, the IPv6 address can be configured by clicking on it and by going to the desktop tab if it is not selected, and then by going to IP configuration. Here we can specify the IPv6 address and the prefix and then the IPv6 gateway. Here the gateway is similar to the IPv4. It is the exit interface of the interface of the router through which a device packet or request can go out of the network. So here it is gigabit Ethernet 00 of the router R1 for PC0. This is the default gateway for PC0. So similarly, the other PCs are also configured with IPv6 addresses. So for routers, if we see how to configure IPv6 addresses, let's go to the router, and if we go to the CLI mode, if we give the command enable, we'll come to the privilege execution mode. So here if we give the command show running configuration, we can see all the configurations that are already done. So here we see that, for example, if we consider this interface gigabit Ethernet 00, interface gigabit Ethernet 00, here in order to configure IPv6 address, we say IPv6 address and then the IPv6 address that is to be configured immediately with the slash, with the front slash, and the prefix specified after it. So this is how we configure IPv6 address. So similarly, all the interfaces of all the record routers are configured with IPv6 addresses. So the next thing that we have to do is to configure static routing for all these routers. So there are four ways how static routing can be configured for a router. One is that we specify the next hop IP address of the router. So that one is called recursive static route. The second one is that the exit interface of the router can be configured for static route. So that is directly attached static route. Third one is fully specified static route, in which both the exit interface and the next hop IP addresses are given. IP address is given. So the fourth one is default static route. It is the IP address with full zeros, which is generally used when in order to specify if the destination does not match any of the entries, it will match this entry and it can be forwarded to a particular interface or through a particular next hop IP address that is generally used to forward a packet to internet. Now let's say, for example, the router R1. This router R1 knows this LAN and this serial network. So we need to specify a static route so that the R1 comes to know about the other 2 LANs and the other serial network. So here if we see, it has been configured like this: IPv6 route. Here we are going to use the recursive static route method. That is, we are going to specify the next hop IP address. So here we say IPv6 route. Usually we use IP route, so here we are using IPv6 route for IPv6 static routing. Then we say the destination network. For this is this destination, this LAN 2001 db812/64. So this is the network address of the destination network, and the next one says the next hop IP address. Since this recursive static route that is specified, we say the next hop IP address through which the packet can be forwarded in order to reach this destination. So the next hop interface is this SC000. So the IP address of this interface is this one, so we are specifying that. So similarly, if we say this network has to be reached, we need to specify it so that it is given, the command is given as IPv6 root, and then the destination network address, which is 2001db8.8002:64, and then the next hop IP address is given. Again, it is the same because that is the way in which the packet can reach this network. Then again, for this LAN, it is given as IPv6 root, and then the destination network address, which is 2001db8.13:64, and the exit interface, it's not exit interface, it's an next hop IP address, that is again given as this interface IP address. So this is how static routing is done for this router. So let's go to the router R2. So here this router knows 3 networks already, that is, it knows these 2 serial networks and this one LAN. So we need to tell this router about this LAN and this LAN. So if we go to the CLI mode and to enable, we can go to the privilege execution mode. So here if we give show running configuration, we can see the configurations that are made. So here let's for example, in order to reach this LAN, we'll give a directly attached static route, which is to specify the exit interface of the router. So let's say IPv6 route, and again the destination, similar to the previous case, the destination network is 2001db8.11/64, and here we say the exit interface of the router through which it has to go out. So here it is serial 000, so we have given that. So this is the way by which we specify directly attached static route. Now we need to tell the router about this network. So let's use a fully specified static route for this purpose. For example, for this case, what we do is IPv6 route, and then the destination network address is given 2001db8.13:64, and then we say the exit interface as well as the next hop IP address. So here the exit interface is SC001, so that has been specified next to the destination address, and then next to it again we specify the next hop IP address, which is the this is the IP address of serial 000 of R3. So here we have given this IP address. So this is how we specify a fully specified static route. So we have configured R1 and R2 with the IPv6 static routing. Then next we will go to R3, and R3 knows this one LAN and this one serial network. We need to tell R3 about this LAN, and the serial network. So here let's use default static route. So how it has been used is, if after we give enable, we go to privilege execution mode. Here if we give show running configuration, we can go and see the configurations that are already made. So the way in which IPv6 default static route has been given is this IPv6 route. Here usually we give the destination, but when we specify a default route, we give a :/0, which represents all the bits of the IPv6 address is 0, and the prefix is also 0, which means it need not match any of the bits in the IPv6 address in order to forward this packet towards this next hop IP address or the exit interface. So here this static route, to specify default static route, we specify the destination as full zeros, and here we can give either the exit interface alone or the next hop IP address alone, or both exit interface and next hop IP address. Here we have used only the next hop IP address, which means this is a recursive static route as well. So this is a default recursive static route. So here we give IPv6 route, then the destination as default route, and then here we get the next hop IP address, which is this. We do this because any destination which is not known by this router has to be reached only via this interface. So we give this interface IP address as the next hop IP address, and we specify a default recursive static route. So we have completed our static route routing configuration process. So let's see, let's have a look at a few troubleshooting commands outputs. So if we go to R2 for example, let's check show IPv6 protocols. So here we see that IPv6 routing protocol is connected, and IPv6 routing protocol is ND is neighbor discovery protocol, so it says it is enabled. Let's check a few other commands. Show IPv6 interface. If we give show IPv6 interface, all the interface, the details about all the interfaces of the router will be displayed. So since it is too much for us, let's say show IPv6 interface, and let's say a particular interface so that we can have a closer look at the details. Serial 000. So when we say this, various details are displayed. Here it says IPv6 is enabled, serial 000 is up, and it says that it is not shut down, it is up. And then we see the link local address, then we see that no virtual link local addresses are configured, then we see the global unicast address which we have configured, and then the subnet is this, which means this is the network address along with the prefix that is given, and joint group addresses are multicast addresses, the solicit nodes multicast addresses. Then there are a few other details which are displayed. So let's also see show IPv6 route. So this will display all the routes that are known by R2 either by itself or by learning through static method. So let's see here whatever is displayed as C are directly connected networks, and whatever is listed as L are local means it can either be the local interface's IP address, this gigabit ethernet 00, serial 000, serial 001, or multicast address like this. So if we look at the other characters, we see that we have S. S says that it is a route that is learned via static routing. So for example, if we consider this router, this route 2001db811/64 is actually this LAN's route, which is not directly connected to this router, and it has learned it via the static routing, and it says via serial 00, and it is directly connected. So here we see there's one more S. So this says 2001db813/64. So that is this LAN, and it was learned via 2001db81001 and :2, and serial via serial 001 it can reach this network. So we see that show IPv6 route lists all the routes that are known by the router R2. There's one more thing that I missed out, that is show. When we go to show running configuration, we see that IPv6 unicast routing was enabled on every router. Now without enabling this unicast routing on all these routers, we will not be able to do static routing. So it is essential that before any static routing commands are entered, we need to enable IPv6 unicast routing. So this has to be done on all these routers. Now let's check whether we are able to connect from every device to the other devices, and that can happen only when every router knows all the other networks, so that it can forward it to the right network. So for example, if we say ping, for example, if we need to connect to this PC2, let's say ping 2001db813:f, which is the IPv6 address of the PC2. So we see that we are able to get the reply, so we are able to connect from PC0 to PC2. So for example, if we check PC1, we see that we are let's check ping 2001db813 and :f. So we see that we again get reply, so we are able to connect from PC1 to PC2. So similarly, for example, if we consider PC2, from here if we give the command ping 2001db813 1 double colon if we are able to get the reply from PC0. Thus we see that all the devices are able to connect to one another. Thank you.